a typical type of problem here. Alright, so they give you these two reactions right here. So you have these two reactions, and they say, what is the Kc? So determine the Kc, and this will also work for Kp. This depends on what they're asking for. What's the K for this reaction? So this is the one that we're trying to get to. Right here. This is what we're trying to get to. This is what we're looking for. And these are the pieces. These are the two equations we're going to manipulate in such a way so that when we add them up, they're going to equal this final reaction here. So you can do this very systematically. Look at the reaction that you're trying to get to, right? And look at all the pieces that you have there. So I'm starting off here with HF. So which of these reactions has HF in it? This first one does. I want HF as a reactant. I have it as a reactant. So I don't have to flip the reaction around, so that I already have it on the right side of the reaction, on the correct side of the reaction. I want 2, but I only have 1, so what can I do? I can multiply this whole reaction by 2. So if I multiply this reaction by 2, I get a 2 there, I put a 2 here, I put a 2 here, and then what do I do with the K? I'm going to square that. And so that's what I wrote down here. So I want to multiply everything by 2, multiply the whole reaction by 2, I'm going to square the K. So I end up with 2HF gives me 2H plus 2F, and then I just squared that K. If you multiply the reaction by some number, raise the K to that power. So I square that, and this is what I get. Now, go to the next reactant. I have C2O42 minus. So which reaction has that? I already used this top one, so I must have to use the second one. And here's the C2O42 minus. I want it as a reactant, I have it as a product. So what can I do? I can flip this reaction. So I'm going to flip this one. Oops. So when I flip this reaction, I take 1 over the K. So if I flip this, that means I make my products reactants and my reactants products. And then I'm going to take 1 over that K. And so that's what I have done down here. Flip this. Flipping just means make the reactants products, products reactants. So I reverse that reaction, and now I take 1 over the K, and that's what that K is. Now finally, the last thing I want to do, I ran out of reactions, so I'm hoping that everything's in the right form. I'm going to add up these two reactions, the ones that I manipulated. So I have, they're the ones that are in red here. It's like, oh, nope, sorry, black. So I have this one and this one. Add them up down here. Okay, so when I add them, I have 2H on that side, I have 2H on that side. They're going to cancel. And so I end up with 2HF plus the C2O4 gives me 2F minus and this guy here. So when I add these two reactions up, this is the final one. This is what I was looking for. If you compare that to the one that they asked you for, put a star by it. This is the same thing as this. So we were able to manipulate the reaction to get everything in the right form. And so when I add those two reactions, I just multiply their Ks. That's what we have over here, and we end up with this answer, 0.12. Alright, so we can do that again. We have another example here. So you might want to stop at this point and work that out. Let's see if we get the same answer. I'll walk you through it. So now we have KPs. So determine the KP for this reaction. So we're looking for this guy. So go reactant by reactant. If you have to go to products, then you have to go to products. Just take them one at a time. I usually just start with the first one. So I have 2NH3 and I have 2NH3 over here. I want it as a reactant because it's the reaction I'm trying to get to. I want it as a reactant. I have it as a product. So what should I do? I'm going to flip the reaction around. So flip it, which means just reverse the reaction. When I reverse the reaction, I take 1 over that K. So 1 divided by that K. That's what I have over here, and I have that all worked out. That ends up being 9.615 times 10 to the 3. Now my first reactant is in the right form. Then I look at I2. So I2 is in this top reaction. I want it as a reactant, I have it as a reactant. I want 3, I only have 1, so what should I do? Multiply this by 3, multiply the whole reaction by 3. So when I multiply this whole reaction by 3, what do I do to the K? I raise it to the 3rd power. I don't multiply it by 3, I raise it to the 3rd power, I cube it. And so that's what we did here. If you multiply this reaction by 3, raise the K to the third power. Alright, and so I have, now I'm going to try to add these two up and make sure that they equal the final reaction that I'm looking for. Let's see, so I have them just copied down here. And what cancels? This 3H2 cancels with this 3H2. So things are going to cancel if they are the same on both sides. So just like when we had to add up net ionic equations and things, we had to cancel the spectator ions. If it's the exact same thing on both sides, it's going to cancel. And so we end up with this reaction, which should look like what we were looking for. Yes, it looks just like that. So when I add up these two reactions, I multiply their K's. And the K's that I'm multiplying are the ones that I already manipulated. So here's my original K. I reverse the reaction, so I take 1 over that K. I get this guy. This one, I multiplied the whole reaction by 3. So I raised the K to the third power, and this is what I get. And then I'm going to multiply those two numbers. So I multiply those two numbers to get my final K, which is pretty big. Now you can look at this K and say, oh, that's a really big K. That's probably product favored. All right, and we can try this last one again. This last one is pretty easy. I just threw in some fractions there. So it doesn't always have to be a whole number. So you start here with N2O, and then you have N2O to start off with. So this one, you don't have to change it around or anything. And then skip the O2 since it's in both of these reactions. You want to leave that one to the very end, and then you can look at 2NO2 as a product, 2NO2 as a product. So you end up not having to change these reactions at all. They're already in the right form. When you add them up here, you have what's going to cancel. That guy cancels. And now you can combine this 1/2 O2 with 1 O2, which will give you 3/2 O2. And everything works out. When you add the reactions, you multiply the K's, and then you end up with 7.9 there.